Hey everyone, welcome to Chapter 4, Section 6, Quadratic Inequalities. In this section, I'm going to go over how to determine whether a point exists in the solution set of a quadratic inequality, and then I'm also going to go over solving quadratic inequalities. So this first example here, I give you a small handful of points, and I want you to identify which ones are in the solution set. So all I want you to do is just plug in the values for x and y, and then just determine if those are, true or false equations or inequalities. So you just have to make sure you substitute it in correctly, and you'll get the right answer. So what I mean is you have all these values, 0, -3, -1, 0, etc. Plug it into this inequality right here, and then you can even use the calculator to give you a true or false answer. So if I'm going to plug in 0, -3, I'm going to plug in 0 for x and -3 for y. So it'll say -3 is less than, and then I have a -x squared, so I'll use parentheses on the outside. The negative goes on the outside of parentheses because it's a negative and then an x squared. So -0 squared minus 2 times 0 and then -1. Okay? You just need to type all that into the calculator and it'll tell you true or false. So what I'm going to do right now is I'm just going to set up these other 3 points, and I'll just substitute them in just like I did with 0, -3. Okay, so here I have it all set up, and like I said, you can just type these into the calculator. If you hit that control and then the equals sign on the calculator, it'll pull up a little menu of different symbols you can type in. So you can type in the inequality symbol, and the first one says it is true. The second one says it's false, and the third one says it's false, and the fourth one says it's true. All right, and so let me show you exactly what I'm talking about here, what I typed into the calculator. This is what my screen looks like on the calculator. You see I got the true and the false statements. So that's how you know which ones exist in the solution set. So I'll just, just to be even more clear, I'll mark out the ones in red, and I'll circle, the ones in green that were true. And so yeah, that's all there is to say about that section. So the next section, solving inequalities algebraically, I wrote use any method previously covered such as factoring or using the quadratic formula. Both of these examples can factor. So what you want to do is just pretend it says equals 0 and then just factor it and solve it like you normally would. And then we'll have to do something a little different for the final answer part. So we'll cross that bridge when we get there. So to start, what are the factors of -4 that add up to -3? Let's see here. So 4 is 4 times 1, and if it's -4 plus 1, that would make -3, and -4 times 1 makes -4. So I'm going to factor this by saying x minus 4 times x plus 1 equals 0. So just write, just write equals 0. Just ignore the inequality sign for right now. And so you get your 2 answers here. Remember, you just flip the signs. So x equals 4 and x equals -1. But since this is an inequality, you need to figure out what am I going to do with the 4 and the -1. So we'll put them on a number line here, right? So -1 and 4. And the original sign was strictly less than, which means I have open circles. All right, and so we just need to test a value like in between. What's in between -1 and 4? Any value that exists in between it. I know the number 0 is in between -1 and 4. So I can test 0, and if it's true, then I'll shade on the inside, and if it's false, then I'll shade on the outsides, okay? So this is what I mean. So my inequality was x squared minus 3x minus 4, so I'll plug in a 0, 0 squared minus 3x, so 3 times 0 minus 4, is that less than 0? So like I said before with the other examples, you can just plug it in and give me a true or false statement, and this one will be true. All right, so since that's true, that tells me to shade in the middle because I chose a number that was in between the two. All right, so because I'm shading in the middle of my number line, I need to write my final answer as x, let's see here, so I say -1 is less than x, which is less than 4. You kind of have to think back to when we first did inequalities and remember that x goes in the middle and the signs point to the left whenever you shade in the middle, and then you'd write an or statement whenever you shade on the outsides. So you kind of have to think back to that section that we did. I don't even remember what chapter it was off the top of my head. But yeah, that's how you would officially phrase the final answer, okay? So let's do one more example. So here I have 3x squared minus 2x minus 5 is greater than or equal to 0. So I'm going to factor this. So I'm going to multiply 3 times -5. So that's going to give me -15. What are my factors of -15 that add up to -2? I know 15 is 5 times 3. And if I have a -5 plus 3, I'll get -2. And if I do -5 times 3, I'll get -15. So I say x minus 5 times x plus 3. And then you can write equals 0 for right now. And so remember, we multiplied a 3 to the back. So that means you have to divide that out next. So I'm going to divide each by 3. And so this one makes 5 over 3, so that means I'm going to have to send that to the front. So it says 3x minus 5. And then 3 divided by 3 makes 1, so x plus 1 equals 0. All right, so now I have it correctly factored. Now I just need to solve it, right? So this one, x will equal -1, right? And then this one right here, you would just look at the previous step and flip the sign, which would be positive 5 over 3, okay? That was the shortcut method I taught y'all earlier in this chapter. So I have x equals 5 over 3 and x equals -1. So I'm going to go do what I did before. I'm going to draw a number line. And so -1 would come first. And then 5 over 3 would come second. That's what, 1.67 or 1.6 continued. And so since this is greater than or equal to, I know I have solid dots here. All right. And so I'll do what I did before, test the number that's in between these two values. I know that 0 is in between -1 and 5 over 3. So I'm just going to test 0 again. So I'm going to plug it into the original equation, which was 3x squared minus 2x minus 5. So 3 times 0 squared minus 2 times 0 minus 5. Is that greater than or equal to 0? That's a false statement. That it would say -5 is greater than or equal to 0, so that's false. So that means I don't shade on the inside, I shade on the outsides. All right? And so since I shade on the outsides, I don't write my answer like I did before with it in the middle. You have an or statement, right? So let's see here. So it's going to the left of -1. That's less than -1, right? So I say x is less than or equal to -1, or, and then it's going greater than 5/3. So I need to say x is greater than or equal to 5/3. And so that's how you obtain your final answer with these quadratic inequalities. It's kind of a strange process, but it kind of goes back to what the first section was, which was testing points. You got to test the point to see if it's true or false, and that'll tell you which way to shade. And so, yeah, that's going to wrap it up for this video. Thank you for watching, and goodbye.